So this section is focusing on knowing your library of functions, your graphs, and piecewise-defined functions. So the first thing that we're going to do is we are going to solve a function, like if you're given a piecewise-defined function, and that's when a function is defined by different equations on different parts of its domain, and that's what a piecewise-defined function is. So what you are going to do is you will find the equation where the x value is in the domain. Now remember, your domain is your x values. So you are looking right here on this side. So that's where the x values are defined. So what we do here is when we find f of -5, you want to look and see where does -5 fit. So is -5 less than 0? Is -5 equal to 0? Or is -5 greater than 0? Well, -5 is less than 0. So what we do is we plug in -5 here. So we would write it f of -5 equals negative, and then plug in -5. And of course, that's going to simplify to +5. Okay, so let me erase this. Okay, so our next one, f of 0, and we're still using the same piecewise function. Now, these will change for each problem. Your equations here are going to change, and your conditions here are going to change each time. They're always going to change, so you just pay attention to what each one is that you're going to be doing. So f of 0, so is 0 less than 0? Is 0 equal to 0? Or is 0 greater than 0? Well, obviously 0 is equal to 0. So we're going to plug it in here. So we have 0 squared plus 3. Well, 0 squared is 0 plus 3 equals 3. And that's our answer. So then for our next one, we have f of 2. Well, is 0 or is 2 less than 0? Is 2 equal to 0 or is 2 greater than 0? Well, obviously that's going to be that one. So we plug it in, 1 over 2, and that's it. That's simplified. Okay, so that's plugging into equations. Now what we're going to do, these get a little bit longer here. For each function, we're going to find the domain, locate any intercepts. We're going to graph it, find the range, and tell if it's continuous. Now, what I like to do is I like to graph it first. Even though it doesn't tell us to graph it first, that's what I like to do. So, what I like to do on these is I like to focus kind of on this part first on my graph. And I like to draw the little, what I call kind of boundaries. And I'm just going to do some little highlighted parts here. And these are not official parts on the graph, but it just helps me establish my graph. So notice here I've got a -3 and I've got 1s here. So what I'm going to do is I'm going to just draw a line here at -3, and I'm going to draw a line here going through 1. And once again, these are not official parts of my graph. I'm not doing dotted line. I just did a highlighted part here. And again, these are not official parts of the graph, but what it does is it just helps me draw my graph. Now, notice -2x plus 1 is here. So the -2x plus 1 is between -3 and 1, okay? The 2 is when x equals 1, so I put it on that highlighted line. And then x squared is going to be over here when it's greater than 1. So it goes in that order. Okay, so this is where these lines should be. Okay. Now, remember from like our library of functions and like from Math 1 and Math 2, -2x plus 1, notice that's in slope-intercept form. Let me erase some of this. Oops. I'm going to erase this so we don't have quite so much going on here. So remember, this should be a line. So between those two highlighted lines, I should have a line, okay? Now, what I'm going to do is I'm going to start with -3, and I'm going to plug it into that equation, okay, to get me a point. So I'm going to plug in -3, that's my x. And like I'm going to plug in, so I've got -2 times -3 plus 1. And when I plug that in, I get 7. Now, notice the inequality symbol, it's equal to. So that is a point. So remember, like if you were doing a number line or whatever, that would be a point. So -3, 7, I put a point right there. Okay. Now I'm going to plug in the 1 for my x. So get rid of that there. So again, I will plug in the 1. And when I plug in a 1, -2 times 1 is -2. -2 plus 1 is -1. And going by this symbol, that would give me a whole. So again, if you were doing like a number line, you would put a whole or parentheses, depending on what kind of number line we're doing. But we're going to put a whole there, so 1, -1 there. And so we just connect, and there's our line. We do it from there to there, and we're not going on forever. We just connect those 2 points because we do this line from -3 to 1. So let me erase this. Okay, so then the next thing, we have 2 if x equals 1. Well, there's not really a whole lot to do. If x is 1, then the y value is just 2, and we've got the equal to, so we know that that is just a point. So our point is at 1, 2, and I just put a point right there. Okay, so then x squared. Remember this x squared is a parabola, okay? So then if I plug in, so my x value is 1, I start at 1. And if I plug in, a 1 squared, then I get 1. And again, if I look at this symbol here, if I plug in a 1, then I get a whole. Now, that's only if I plug in the exact value of 1. So at 1, 1, I get a whole. Now, anything beyond that is okay. It's only if I plug in the 1. So if I plug in, say, if I want to keep drawing this parabola, if I plug in a 2, so like 2 squared gives me 4. So if I get 2, 4, now remember this is a parabola. So it's going to have that curve shape to it. Okay, now 2 is greater than 1, so that's okay. So that's why I did a point there, okay? It's just that 1 is not greater than 1, so that's why that had to be a whole on that line, okay? So here's my graph, and that's part C. So I've got part C taken care of. So now let's do the other part. So my domain. So if I can do this one of 2 ways. I can look at this here and look at my domain, or I can look at my graph, either way. If I look up here, I can see that it starts at -3, and it goes from -3, it's equal to -3, and it's got the equal to, and then it goes to 1, but then it equals 1, and then it's greater than 1. So it goes beyond 1, like x is greater than 1, so it's going to infinity. So that's kind of one way to look at it. I like looking at my graph because I'm a visual person. So if I'm looking at my graph, you look at your graph from left to right. So we can see that it starts here. This is the furthest left it goes. And again, we're at -3 here. And if we go from left to right, we can see that as I move from left to right, even though we have holes here and here, I do have this point that's there. It's got the x value. We do have a solid point at 1, even though we have a hole at 1. We do have a x at 1, and then it's going here. We've got the arrow here. It's going up and to the right forever, so that covers infinity. Okay, so we've got that covered. All right, let me erase my green dots here. Okay, and we'll color this back in pink. Okay, so then intercepts. Now, intercepts. We can see that I've got an intercept here and an intercept here. So that's kind of like the visual part of it. when we do the graph first. So I see that I've got a y-intercept and an x-intercept, and it's that line, and that's coming from here. So if I do my x-intercepts first, then I have negative 2x plus 1 equals 0. Negative 2x, and move the negative 1 to the other side, divide by negative 2. So basically x equals 1/2. So I have 1/2, 0 for the x-intercept. And that line also gives me a y-intercept. So then if I set it equal to 0, oops, I forgot my negative. So then if I move the 1 to the other side, oh wait, whoops, I was doing the same thing there. Okay, so if I do y equals negative 2 times 0 plus 1, then that just gives me 0 plus 1, or y equals 1, so my y-intercept is 0, 1. Okay, so the graph helps give me a visual. Now, if I wanted to look at my other two parts of the equation, like the 2 and the 1, okay, so if I look at that part, well, 2 can't equal 0 because, well, 2 equals 1. Or, like at 2, at the y value of 2, the x is 1 for that. Okay, 2 doesn't equal 1. Let me redo that. That doesn't really make sense right there. But when x equals 1, y equals 2. So, and then like our x value, like x is, like our x value is 1, so we can't ever make x equal 0. We can't plug in a 0 for x. So we can't ever get a y-intercept by plugging in 0 for that. And like the same goes for the y. We can't make a y equal 0 because our y value is 2. And then for the x squared graph, we can't plug in a 0 because the x is greater than 1. So we can't plug in a 0 for that because x is greater than 1. Okay, so we can't get an intercept for that. Okay, and then also obviously we can look at our graph and we can see that it's not crossing the y-axis, and we can see that it's not crossing the x-axis. Okay, so then for the graph, we already have our graph on here. And for our range, you look and see how low that your graph goes. So this is the lowest point that our graph is. The lowest, and you look at the y value for that. The lowest y value is negative 1. And since there is a hole there, then you get a parentheses for that. And you look and see how high it goes. And there's a hole right there. However, at the same y value, we have a point, so we don't have to worry about stopping. And here, it goes up forever, so we go to infinity. And then for part E, we're going to tell if our graph is continuous. And we do have holes here, so it is discontinuous. At x equals negative 1. Okay, so that concludes that example. So we'll do another example here. Okay, so we'll start with graphing. So again, what I like to do is I like to draw kind of like my little, what I call the boundaries. Again, this is not official part of the graph, but it just kind of helps me establish each section of the graph. So I have a 0. So I'll draw my line here. And then I have the 3. So I'll draw my line here. Okay. All right, so 1 over x. So you remember if you look that up on your library of functions to see what that graph should look like. And again, we will start by plugging in a 0 because it has to be less than 0. And actually, we can't even do 0 because 1 over 0 is undefined. So we can't even do 0. So let's do -1. So 1 over -1 is going to be -1. So we get -1, -1. So there's that point. And remember, this graph is going to look, it's got that curve to it. So that's what that graph is going to look like. This graph, remember, is just going to be a line. This one we can plug in a 0. So 2 times 0 is 0 plus 1 is 1. And this one is a point because it can be equal to. So we get 0, 1. And then we will plug in 3. We plug in like the beginning and the end. So 2 times 3 is 6 plus 1 is 7. And that point is a whole. So 3, 7 is a whole. And we just connect those two to get our line. And this point, we will plug in 3 and we will get 5. Whoops, I wrote the wrong one first. So we will get 3, 5 to start us off with. So 3, 5. Now, because it's greater than or equal to, this is a horizontal line, okay? So this is going to extend going this way, okay? So whenever it's greater than or equal to, or less than equal to, it would be going to the left if it was less than or equal to. So if it's greater than or equal to, this is a horizontal line. If it's just equal to, it's a point, like on the previous example. But since it's greater than or equal to 3, we get a horizontal line. Okay, so here's our graph. So then for part A, our domain, and so you can either go by the x inequalities or you can look at your graph. So either way, so we can see on our graph, we can see that we've got our arrow going to the left forever. So that's going to be -infinity. And notice that we've got that asymptote there, but we do have a point on 0. Okay, so we're good with 0. And then even though we have a hole, even though we got a hole right here, we do have a point right here, so we're good. And it's going to the right forever. Let me switch and do pink. So domain is -infinity to infinity. So part B, our intercepts, we can see that we do have a y-intercept there at 0, 1. Okay. We know that, so if you want to do it, like just kind of thinking logically here, like if we look at the 1 over x, we know that we don't have intercepts because like we can't do 1 over 0 and plug in a 0 because that's undefined. And again, if you set it equal to 0 and you multiply by x, like move the x up and over, you would get 1 equals 0, and that doesn't work, okay? So we have no intercepts like on that fraction. And then, so this equation, so the y-intercept right here came from the 2x plus 1, you know, just by looking right here on that graph. We have no x-intercepts on that one because the x, we can't, because what happens here, if you do 2x plus 1 equals 0, so watch what happens. 2x equals -1, and if we divide by 2, we get x equals -1/2. Well, look what the x values can be. X has to be between 0 and 3. X can't be 1/2 because x equals -1/2 doesn't follow the rule. It says x has to be between 0 and 3. So this doesn't work. Okay, so we didn't. So we have no x-intercepts on that part. And then if we go to the, this part right here, well, that's just a horizontal line. That's 3, 5. It's a horizontal line. It starts at 3, so it's not going to cross the y-axis. And it's just, obviously it's at a y value of 5, so it's not going to cross the x-axis. We can't plug in a 0. There's going to be no y-intercept because we can't plug in a 0 for x. And there's no x-intercept because x has to be greater than or equal to 3. Okay, so we're done for that. Okay, then for part C, that was our graph. We've already got that done. Then for part D, our range. So we see this going down forever. So that's negative infinity. We go up now. Right here, right there, we have that asymptote. So we have to stop at 0. And we have a union. Now we have the point there at 1. It is a solid point, so it gets a bracket. And it stops at 7. And since 7 is a whole, it gets a parentheses. And then it is discontinuous at, and you see it's discontinuous right there. We have a whole at x equals 3. Okay, so it's discontinuous anywhere you have holes and you use the x value. Okay, so last one. If we do our graph, so I'm going to just draw my boundaries in here. So I've got a -3, and I've got a 1. You don't have to draw these on here. I just like to because it helps me. It's just something I like to do. It's a personal preference. These are not, again, these are not official parts of the graph. Okay, so this is a line. That's going to give me a line. If I start, I'm going to plug in a -3. So 2 minus -3 is going to give me a 5. And this is a point because it is the equal to there. So -3, 5 gives me a point there. And then if I plug in 1, 2 minus 1 is 1, and that is a whole. So 1, 1 is a whole, and I draw my line. Then this, look on your library of functions to remind you what that graph is going to look like, your square root graph. So first, I'm going to plug in a 1. Square root of 1 is 1. So I get 1, 1. Now that is a point. Notice that's in the same place as this one. So I would fill that in. So a point overrides a whole. Okay, so if you have a point that's in the same place as whole, fill it in. Okay, then I'm just going to plug in another point to help me establish my graph. So I'm going to plug in 4. The reason I pick 4 is because the square root of 4 comes out nicely. I don't want to pick 2 because the square root of 2 is a decimal. So I'm going to pick something that's a perfect square. So the square root of 4 gives me 2. So 4, 2, and remember kind of what this graph looks like. It just and it's going up slowly like that. And it just keeps going up forever. Like I can plug in 4, I could plug in 9, I could plug in 16. I could keep going up because x is greater than 1. I could keep picking large x values, anything bigger than 1. So there's my graph. Okay, so now we're ready to do our domain. So for our domain, we can see that it starts at an x value of -3. And it's a solid point, so it gets a bracket. And if we move from left to right, it goes forever to infinity. So for B, our intercepts. So if we look at the graph, we can see that we have a y-intercept, and that line 2 minus x is what gives us the y-intercept. So if I want to find the y-intercept, then I can do 2 minus x, or sorry, not 2 minus x. I would plug in a 0 for that, so 2 minus 0 equals y. And so 2 equals y, so I would get 0, 2 for my y-intercept. Okay, I know that it's not going to have an x-intercept because if I did 2 minus x, equals 0. So this is why I know it's not going to have an x-intercept. 2 equals x. Well, x can't be 2 for that particular line because if I look right here, x has to be between -3 and 1. And 2 is bigger than 1. So that doesn't work. So there's no x-intercepts for that line. And obviously I can look at the graph and I can see that it's not going to have an x-intercept. So the same thing happens for the square root graph. I can look at it and I can see that there's no y-intercept for that, also no x-intercept. But the same thing would happen if I plug in zeros for either x or y. So like if I do this for like my x-intercept graph, if I do square root of x equals 0, well, if I square, square both sides, I get x equals 0. Well, x has to be, it tells me x has to be greater than or equal to 1. So that breaks the rule there for that. So there's no x-intercept according to my rules over there. And same thing for y-intercepts. Like if I'm doing this algebraically, instead of looking at my graph, then square root of 0 equals y. Well, 0 equals y. And I can't plug in a 0 for x because, again, I have to plug in something greater than or equal to 1, and I'm breaking the rule by plugging in 0. So algebraically, I'm breaking the rules. Okay, so for C, I already have my graph. For part D, my range, my lowest point is, my lowest y value is a 1. And this right here is telling me that it's going up forever. It's going up slow, but it is going up forever. And then part E, I have no holes, which makes this continuous.